As large language models become more powerful and sophisticated, so to do the techniques we use to interact with them. Among the most effective prompting strategies are chain of thought, self consistency, and tree of thought prompting. So, these methods go beyond basic prompting by enabling models to simulate reasoning, evaluate multiple solutions, and explore branching paths of thought. So, in this video, we will break down each technique from scratch, and also I'm going to explain how they work, and I'm going to highlight their key differences. So, what is chain of thought prompting? So, chain of thought prompting is a method that encourages the model. So, chain of thought is a prompt engineering method that encourages the model to generate intermediate reasoning steps before arriving at a final answer. So, instead of jumping directly to a conclusion, the model is prompted to think aloud or show its logic in a step by step manner. So, actually, this mimics human problem solving and helps the model to tackle complex or multi step tasks more effectively. So, how it works? Simple. You provide a prompt that may include or may not include a few examples where the thought process is explicitly shown, but you ask the model to follow the same approach. If you given some thought process example for the same approach for a new input, you may ask the model, let's think step by step to arrive at a final conclusion. I know this would be confusing. So in our previous video uh, on hands-on demo, you saw that we prompted like, let's think step by step. So in that video, I haven't given any examples, but rather than directly jumping to the solution, I asked AI model, let's think step by step. So that AI model given a step by step solution to me, and finally it given a answer. But chain of thought prompting is used in two ways. So in the prompt itself, you may ask like, let's think step by step, or you can use few shot prompting or one shot prompting. Like you can give an example, and for that example, you explicitly define the reasoning process and you give a new input and say the model follow the same approach. So let's consider this example. So we have this prompt where we given some examples explicitly and then we asked a similar question. So here the prompt is, so John has 5 apples, he gives 2 to Mary and buys 3 more. How many apples does he have now? And here we give an answer. So let's think step by step. So John starts with 5 apples, he gives away 2, so 5 minus 2 is equal to 3. Then he buys 3 more, that is 3 plus 3 is equal to 6. So final answer is 6 apples. Now when given a similar question like Sarah had $10, she spent $4 and then earned $7, how much money does she have now? So the model should generate like, let's think step by step. So Sarah starts with $10, she spends $4, that is 10 minus 4 is equal to 6, then ends $7, that is 6 plus 7 is equal to 13. So final answer is $13. So here you can give one example and you can give a thought process and you may ask the similar question. So this is also one way for chain of thought prompting. So the second way is you can just add a prompt like, let's think step by step to solve this particular problem rather than directly going to the final output. So both are considered. Now let's see some of the use cases for chain of thought prompting. So chain of thought prompting is highly useful when you are dealing with math problems, when you are dealing with logical reasoning, when you are dealing with problems that have complex decision making, or when you are dealing with a task that requires explanation. So for these all these use cases, chain of thought will be super helpful. So now let's see some of the advantages for chain of thought prompting. So chain of thought prompting really improves accuracy on multi-step tasks, and also it makes the model reasoning more transparent, and also it encourages logical consistency, and also it have some limitations. Sometimes it can be verbose, it may propagate errors if early steps were wrong. Hence, to avoid this limitation, self consistency prompting is introduced. So self consistency prompting is nothing but voting for the best answer. So, what is self consistency prompting? So, self consistency prompting builds upon chain of thought by generating multiple reasoning paths for the same question and selecting the most consistent or common answer. Instead of relying on single chain of thought, the model explores different ways to solve the problem and pick the one that appears more frequently or makes the most sense across multiple attempts. So actually how self consistency prompting works, so here you ask the model to generate similar answers using chain of thought, then select the most consistent one. So here you are asking the model to generate several answers using a technique called chain of thought, prompt engineering technique, then select the most consistent one. So let's consider this example prompt. So if it takes two workers 3 days to build a wall, how long would it take six workers to build the same wall? So here you need to ask the model to solve this using CoT three times. So here you are going to ask the model to solve this using CoT three times. So here you may have three thoughts. Okay, like thought one, more worker means less time. So two workers 3 days. So six workers 1 day. So the thought two will be like total work equal to 2 into 3 is equal to 6 man days for 6 workers. 6 divided by 6 is equal to 1 day. And thought 3 would be like since doubling workers half times, tripling them reduces time to 1 day. So all three chains lead to the same answer, that is final answer is 1 day. So coming to use cases, you can use for the ambiguous questions, you can use for the task with multiple valid approaches, you can use where the situations where like correctness needs verification. So some of the advantages for self-consistency are like it reduces error propagation, it increases robustness, it enhances reliability through consensus. Okay. When it comes to limitation, self-consistency is really computationally expensive because it generates multiple reasoning paths and it may implement a function like voting function to select the final most consistent answer, and also COT may not always converge to a unique solution. Hence, most robust prompt engineering technique is proposed, that is tree of thought prompting, where we are going to explore multiple paths like a branches in a tree. So what is a tree of thought prompting? So tree of thought prompting is a prompt engineering technique that allows the model to explore a branching structure of the thoughts like a tree. Each node represents a potential idea or partial solutions, and the model evaluates and selects the best path forward. So this goes beyond linear thinking like COT and introduces a search-like mechanism or possible reasoning path. So how it works? In tree of thoughts, the model generates multiple candidate thoughts at each step. It evaluates these thoughts based on coherence or likelihood. It selects the best next step, possibly backtracking if needed. It repeats until reaching a final answer. For example, consider a prompt, generate a creative story about a lost robot in a forest. So here the model may generate three initial ideas, like the robot finds an old map and follows it. Idea two, where like the robot meets an animal who help it find home. Like it generates three ideas, it evaluates which idea leads to the most engaging narrative and expands on that branch. So and it continues with that prompt forward. So here uh, tree of thought have really a lot of use cases when it comes to creative writing, planning and strategy, problem solving with multiple options, open-ended explorations. And also tree of thought have many advantages and limitations that we already learned in our previous videos, like it enables strategic exploration, it is really better suited for non-linear problems, it supports backtracking and re-evaluation, etc. When it comes to limitations, it requires careful design of the search process, it requires higher computational costs, and not all LLMs naturally support this without additional frameworks. So now let's learn the differences between COT versus self consistency versus TOT. So when it comes to structure, chain of thought always follows linear. That is, it always thinks step by step. When it comes to self consistency, it uses n chain of thoughts. That is, it explores n reasoning paths where and also it select the most consistent output. When it comes to tree of thought, the structure is like branching tree structure. So when it comes to number of reasoning paths, chain of thought always uses one. Self consistency uses multiple reasoning paths. Tree of thought also uses many number of reasoning paths. When it comes to exploration mechanism, tree of thought doesn't follow any exploration mechanism. Self consistency follows voting mechanism where the most consistent answer is picked based on the voting. When it comes to tree of thought, the mechanism is search and evaluation. So when it comes to backtracking, there is no backtracking involved in chain of thought, and also there is no backtracking involved in self consistency, but there is backtracking in tree of thought to select the most consistent reason reasoning path. Okay, so when it comes to best use cases, chain of thought is really useful for multi-step logic. Self consistency is very useful for accuracy verification. Tree of thought is really useful for creative strategic task. So when it comes to computational cost, the chain of thought takes low compared to self-consistency. So self-consistency take a medium computational cost. Tree of thought takes high computational task. So when it comes to output consistency, chain of thought is medium, self-consistency is high, tree of thought is again from medium to high. So here self-consistency output maintains high consistency because it selects the most consistent answer from the outputs it generated. So when to use which technique? So use chain of thought when you need step-by-step reasoning, when the task involves logic or math, when you want the model to explain its thinking. So use self-consistency when you are dealing with ambiguous or uncertain inputs. You want to verify correctness through multiple paths, so the task benefits from the consensus-based decision making. So use tree of thought when the problem requires exploration of multiple possibilities, when you are working on creative or planning tasks, when you want the model to explore, backtrack, and define its approaches. So advanced prompting techniques like chain of thought, self-consistency, and tree of thought empowers user to harness the full potential of large language models, while traditional prompts give direct instructions. So these advanced methods gives model to reason, verify, and even strategize. So which brings us closer to simulating human-like thinking in missions. So by understanding when and how to apply each technique, developers, researchers, and AI enthusiasts can dramatically improve both the accuracy and the depth of responses generated by the AI systems. So thank you.